On the next problem, we're going to compare factoring and the quadratic formula. So first we're going to solve this quadratic equation by factoring. The equation is 2x squared plus 11x minus 6. So what I want to do on this problem, because I have a trinomial with the a greater than 1, I'm trying to find numbers that multiply to negative 12, right, we make our rainbow, and add up to 11. So those numbers are positive 12x and negative 1x. If you need to go back to the zero product property lesson or even the trinomial factoring lesson, which is lesson 14, to go over that method, you can. So from here I group, take out a 2x and x plus 6, take out a negative 1 and then another x plus 6. So now I take out my x plus 6 and 2x minus 1. This is an equation, so we're not just factoring, we're solving. So we get negative 6 and positive 1/2. Now we're going to solve this same quadratic using the quadratic formula. So my a, b, and c values are 2, 11, and negative 6. So with the quadratic formula, I want negative b plus or minus the square root of b squared minus 4ac over 2a, so that's 2 times 2. And the simplifying would give me negative 11 plus or minus. This simplifies to 169 over 4. Now, 169 is a perfect square, so this actually, we can get rid of that square root. We have rational answers, so this is a negative 11 plus or minus. The square root of 169 is 13 over 4. Now, since I have the square roots gone, I have to do further simplifying. So my first answer is negative 11 minus 13 over 4, which is negative 24 over 4 is negative 6. And my second answer is negative 11 plus 13 over 4, which is positive 1/2. So these two answers I see are the same answers I got solving with factoring. So that's a way you can compare this. Every equation, the quadratic equation, can be solved with the quadratic formula. Some can be factored. If you can use both, you should get the same answer. Our next problem says verify your solutions using a graph. To show your work, rate the function you graphed, the points you used to find the solutions, and the actual solutions. So if I wanted to check this graphically, I would graph 2x squared plus 11x minus 6. I would look at the graph, the points I would find, I want to know when that function is equal to 0, so I would find the x-intercepts. I could use second calc 0 for that, and those points would be negative 6, 0, and 1/2, 0, because factoring, quadratic formula, and graphic methods should all give the same solutions. So my solutions would be, like the other two problems, negative 6 and positive 1/2. We just used the graph to find them. Looking at the next one, sometimes we have to use the quadratic formula and we want rounded answers. So these are actually the easiest ones. That rounding tells me that I'm probably not going to be able to factor. A quick check looking for numbers that add or multiply to 13 and add up to negative 8 shows also that I'm not going to be able to factor. So plugging these numbers in, negative b is negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 13 all over 2 times 1. Now I want my answers to the nearest hundredth, so there's no need for me to simplify. I can actually type these in my calculator, so I can make a fraction. I'm not going to simplify anything just to show that I do not need to simplify at all, and I will get the right answer. So I'm going to type this, the first solution, which is negative 8 minus, so I'm going to use the minus first just because I like to get the smaller one over with, over 2 times 1. I could simplify parts of it, right? I could make this a positive 8, I could make this a 2, but if I just type it right in, that will give me the solution to the nearest hundredth, which is 2.26. If I type in the same thing, but I make this a positive sign, right, that would be plus or minus, the other solution has a plus there, that would be 5.73. So these are my two solutions. Verifying my answer with a graph. If I were to graph this, so if I were to graph y equals x squared minus 8x plus 13 on my calculator, I would, and I did second calc 0, I would see that these two are the zeros, the 2.26 comma 0 and 5.73 comma 0. At the bottom of this page, we're just going to practice 2 more quadratic formula problems. I'm going to be pretty quick about going over them. If you need to go back to the other page, that's where I go a little more slowly. So I'm just going to set up my quadratic formula first. Negative b, negative negative 2, plus or minus the square root of negative 2 squared, minus 4 times 2 times negative 5, all over 2 times 2. So once I type in that radicand, that's going to give me 2 plus or minus the square root of 44 over 4. Simplifying the radical gives me 2 plus or minus 44 is 4 times 11. So square root of 4 is 2, and then radical 11 over 4. Simplifying, I have a common factor of 2. So my answers here, I'm going to write them in roster notation, are 1 minus radical 11 over 2, and 1 plus radical 11 over 2. The second problem, 4x squared plus 12x plus 9. We have, for quadratic formula, x equals negative 12 plus or minus the square root of 12 squared minus 4 times 9 all over 2 times 4. That gives me negative 12, and interestingly, plus or minus the square root of 0 over 8. Now, what's kind of weird here is, right, this just goes away. So I actually only end up with one answer, which is negative 3/2. That's odd for a quadratic, but we actually, when we end up getting the same answer because of this situation, it's really the only time we get just one answer. Factoring, if I factored this, it actually factors into 2x plus 3 and 2x plus 3, which further shows, right, each of those factors would give me the same answer, so we call it a double root. We'll look at those graphs next unit.